Hey, let's take a look at this coffee grinder and remix it for a cooler design here. I'm going to actually just pop into my iPhone here, open Onshape, and scan my coffee grinder. This is a demo model that I've used many times over the years with Onshape. I've put it away for a little while, but it's time to dust it off because there's some cool new ways of doing work in Onshape that lead to some interesting workflows like this. Like I can literally 3D scan this object now in Onshape right from my phone. I don't need to like go to any other software. I just go to Onshape. I have a scanner on my phone, right? You know, every modern device seems to have those kind of things lately, right? And when I look at my coffee grinder here, it'll allow me to kind of see it. It puts it in an envelope, and I can push and pull this square envelope here, rotate it. So that way, when I import it into Onshape, when the app does it for me, essentially, everything will be lined up with proper planes. Now, because, we have all this LiDAR and cool scanning stuff inside of phones, we can just scan the object. So, this takes about 5-10 minutes of walking around the model. Once you get it, from the bottom and the top and you walk around it, it will then process it on Onshape's cloud, right? Onshape's using, cloud services. It's a full SaaS app. Your computer or phone is not, overheating, because of this. It's going to process the mesh. It's going to then upload it to Onshape, create a mesh, right, that you can use to help reference different parts of your design instead of taking hand measurements. So there it is. It's a little lumpy, but we're going to get, this full view here in Onshape. I've changed the view of it a little bit just to make it transparent, a little easier to tell the difference between the mesh object and the regular BREP CAD models that we'll be building around this. We'll actually take some geometry from this, but first step, I want like really nice sketch-based geometry, right? And now I can kind of see the shape that I have here, and I'll just, construct using the center plane, a center point rectangle, right? Nothing too crazy there to worry about. All right. So we got our parametrically driven dimensions here. Of course, we can make these construction objects as well. I hit the letter Q on the keyboard to do that. And let's try to whip in a Bezier spline in here. Let's see, how many clicks it takes to get the spline that we're looking for. I'll just whip that around. Let's try that again. In fact, we're going to increase the degree of the spline here by adding several points along the way. So I was using that rectangle there to kind of help me, construct the shape into place, right? And, I can drag that around. Right now, I can make that tangent, but of course, that degree, 6 degrees, 6 points on that Bezier is not required, right? So, what we probably want to do is just try one more time here and just go down to 3 instead of 6 points. And that will get us very close to the shape that we're looking for. We get this nice kind of concave fish looking shape here. All right, let's hide that mesh. And now we have a nice parametric sketch with an arc and a line instead of, dealing with mesh objects. And I know the height, of this needs to be a certain distance, right? So let's just start with around 6 inches or so. And we're going to make a plane there because I want to sketch another kind of shape that looks like this, referencing, the mesh kind of in place here, right? So, of course I can, maybe I'll just offset the spline right here inward. That Bezier, I'll just offset it in, pick an amount. We'll play with that number once we turn the scan on here. Now I can kind of get it close to the scan here. Let's, see 6 a little further away. Let's go up to around 10. And that looks pretty good to me. I just need to connect dots here just to get a fully closed region. And you can see the region kind of close up there with that shaded area when I close that sketch. So, now we have a shape here in place, but I noticed that that vertical or that back wall is a little further away than I really want. So let's delete it, just pick delete off the keyboard, erase the line, and I'll just offset that a little bit more as well and bring it into where I think it should look good. Let's pick around 8 millimeters here. We need to trim it out, so we just pick trim and use the power trimmer, just buzz right through. I love doing that. All right, we're looking good. All right, so we have two profiles that we're going to loft between. Essentially, that's one of the great surfacing construction techniques. I'll hit letter S on the keyboard that bring up my customizable toolbar, and I'm going to choose different end conditions here to get it to blend perpendicular from the base to the top with a certain magnitude. So we'll pop that out. You notice by changing that number for the start magnitude, it bulges out a little bit, still remaining normal to the bottom of the part. All right, let's name this part. So for all intents and purposes, this is like going to file save as // save, saving it with a name. But in Onshape, everything's a database driven system, and you have, just parts appearing as you create new geometry here in this part studio environment that Onshape generated for me right from the scan, right from my phone, right? All right. So I can see I'm kind of close to the look and feel of this. As I said here, every single change has been captured in the history of this document. You can label major milestones here with a version identifier. So I'll just call this version 1. And then, let's make a change or something just to show some differences here. And, there's another change that just happened. I'll set it as version 2. It's not required, but it makes it easy to kind of tell a story. Of course, you need to have a full version to branch off and try out design alternatives. So from version 2, I'm branching off and creating a style branch and a design for manufacturability branch. Okay. So let's go to the style branch and do some work. So this is an independent place, independent of the main branch. So somebody else opened up the main design and I'm working on style. My changes aren't going to get in the way of anybody else's changes. That's one of the reasons for a branch, but it's also a nice stylized alternative. Let's use the mesh now to actually create this kind of surface on the top of the model. So we're literally just picking a bunch of points on that mesh that came in, and we're fitting a constrained surface through those points at a tolerance of 0.01 millimeters. You can see there's a tolerance and optimization algorithm that is available. And I'm just going to pick as many points as I think I need to get it to look the way I want. Of course, I could have gone the other way and just sketched out arcs and created surfaces, but the constrained surface is really going to give you a nice smooth surface, proper, proper geometry essentially that you can use. And I'm going to replace the flat surface there with the new curved surface, just like that. And there's a surface model. I can hide that. So you can kind of see we're kind of mimicking that shape of the top of that profile in both axes, like an X and Y axis. We're able to get like that nice curved shape without a lot of work at all, as you can tell. Get the look and feel. So now let's actually split the part into two pieces, so we can actually have a separate cover from this kind of body in white shape, the clay model, if you will. Looking at this, and I'm looking for a place to cut it with, and I had a plane before. I could have used that. Let's we'll actually show you this mate connector function as well. A mate connector is like a plane and a point kind of had a baby, and they're working together. Okay, so here we have that mate connector, and I can use that as the place to split my part. I could have done that, like I said, with that plane I had earlier, but you know, it's always good to talk about make connectors and their utility. All right, now when I split it, it created a brand new part, which I've renamed instead of going to file, save as, whatever, right? Yeah, I'm just going to rename it right here in the list, in the database. And now we have the base and the cover, two separate parts. And I've established two different materials on that as well. I'm just going to roll back in time before the split and throw in a fillet radius, on those sharp corners. So rolling back will help you, work at a state of the model that's more simple, right? I want that edge to be filleted before I cut it instead of having to pick four, edges to cut. Now I'm picking two edges to cut, right? With a fillet radius. And, I'm going to use a curvature continuous radius 20, which is a nice blended shape, right? C2 continuity, as they say, right? So now we're getting, our shape in place here. Now, I want to play with the shape just a little bit here, I think. I think I want to go to this plane here that I was referencing earlier, and I'm going to hit the powerful final button. And using the power of cloud, AWS, I'm rebuilding this model in real time simply by dragging that arrow around. And remember, I'm on a browser. I'm on my Mac. This is insane that I can do this just by clicking and dragging in a web browser, seeing the full model tree rebuild, with that final button. That's the power of the cloud. And I'm just going to go in and hit the final button again and alter a few of these parameters like that magnitude there. And that's getting a little closer to the shape that I was hoping for. All right. So, if I turn the scan on, you can see I'm really pretty close, to the scanned image, and probably a little better, of course, because of that. And, I'm using real B-rep geometry now. I want to get that curve in there, that really complex curve that kind of makes the style really pop on this design. So I'm just going to look at this, slice through the middle and put in a 2-point Bezier spline in here. Let's do something like this. That's 2 points. 1 point in the middle. And I'll just drag that point. And when you have that point, you can do lots of different things with it. So, when you're in a tool like a Bezier spline, it's all about, seeing how it looks, right? Pushing and pulling, looking at how this kind of, interacts with the rest of the geometry. So as I drag that down, I can work with it. I can even add dimensional information to it. I want that spline to be 5 millimeters from the top of the cover. So that way it always adapts to that geometry, right? All right. And let's try this first. We'll see if that curve goes to the outside, what would happen. And we're going to, it's all about design change here. I'm going to go around and try a few different things here to see how things look. I'm going to use the powerful split face option now. And not splitting parts, but splitting faces. So that way we can use that curve to split these faces up, right? So I just window around those and pick the curve. And now we have this nice split face that we can use for a variety of purposes. Maybe a simple thing to do instead of like doing a bunch of surface modeling or something like that is just to use the Onshape direct modeling tools like Move Face. I'll just pop that out by 5 millimeters and there we are. Now I don't know if I like this perfectly, right? I might want to, round off the corners. I might want to pop that surface back into the back. I just want to try a few things out, see what happens here. So, it's a nice looking surface, right there. But, the back of that isn't exactly the way I really want it. So let's go back to the sketch for the cosmetic curve here that I'm working on. And I might even just get rid of that dimension, delete that dimension. Right? Hit the final button so we can see things update. Maybe if I put the curve and pierce it through that back wall, maybe that'll look good. You can see my feature tree rebuilding, including, some unexpected results, which you're going to be able to take care of as you continue to do your work. So, it's just doing what I told it to do. So let's go ahead and modify the geometry here just a little bit more. We'll just delete those features for now. And I kind of like the look of this as it kind of blends to the back without a punch out there. So I want to adapt my geometry to work in that way instead. How can I do that? It looks like that back curve actually needs to come in a little bit based on that scan that's helping me out. All right. So let's edit this. Look at this right from the side. And yeah, that's pierced. So let's just unpierce it by deleting that relation and moving that inward. And of course, I can add, reference geometry to the midpoint of that radius if I wanted to. And I can even add relations to the Bezier kind of control grid that is a part of that Bezier curve, which really gives us this beautiful kind of nice blend, perpendicular to the bottom and to the kind of side. All right, let's just pull that in all the way now to the front of that radius. All right, so I think this is looking pretty good. So let's do our, move face operation again, to push those surfaces out. Yeah, that's going to look nice, I think. It's actually a much simpler design, but it looks really nice. And of course, we'll round off the that sharp edge. So, I got equal radius. I got a measurement as a width or a radius. You have different choices, for different types of fillets and Onshape, right? It's going to give you good error handling to show you areas where, it may not work based on the geometric conditions, right? Maybe a width fillet isn't really the best choice here. Let's try radius fillet. And we'll bump that radius out a little bit, see what we can work with. Yeah, I think that looks good. Goes all the way around. Just do a little spin around to inspect it. Looks nice. All right. So we're getting pretty close to the shape that we're really hoping for. We might want to round off a few more pieces, of this, of course, before we get to the design for manufacturability phase of this, where we need to create wall thicknesses and all that, right? So let's just we'll bump this up to equal curvature anyway, just see if that gives us a little better look. Matches the rest of the styling of the model. So I like the way that looks. All right, another radius right there on the top. So it's really nice being able to work on both of these parts together without having to worry about file save as type operations, right? I'm just kind of adding my geometry, designing the model, regardless of how many parts it has, right? Just giving one small radius there on the outside to break that sharp edge. All right, we're looking pretty good. Let's do a quick comparison between, the style and the main design, perhaps, just to kind of get an understanding of how far we've come in the last 20 minutes or so in design here. So here I have my DFM branch and my style branch. I haven't done any work on my DFM branch yet, so I'm just going to compare it to that. But I can see, this is my progress since, we started kind of branching off. I have all those features created, and I have a loft that's different between the two variants as well. So really nice to be able to get that understanding. You can't do that with a pack and go file save as, really easily. It's just, because Onshape has the full history of everything, you're able to see everything and even merge, that information back into the DFM branch where I'm going to continue doing my work, right? So nice workflow to kind of go through that way. All right, let's hollow this thing out, get a nice wall thickness. We're going to have cast and injection molded parts on here. Onshape is giving me nice error reporting, showing me in red, where that shell was not having a good time, but we just changed radius value or wall thickness value, and we're good to go. All right. So we have our parts here, but we need a place to mount this motor, right? If you think about this, we're going to have a motor inside of here that's spinning a blade. We need a place to have the coffee grounds kind of in a little well, if you will, inside of this cover. And right now, this is just a hollow wall. We need to create the inside pieces. So I'm just going to search for my plane tool, and we're just going to pop down from that make connector at 15 millimeters to create a wall, or 20 millimeters for this well. And how will I create this locate? I want where that plane is to essentially be, the bottom of the well there, right? Let me just update that shell so we can see through it. I'm going to have that open anyway later. And let's, we don't really need that plane. That was, let's do it in the side view here and just draw a single line. Okay, and we're going to use the rib tool essentially. So I'll draw a line where I think I want that. Maybe I'll turn on my hidden edges just to make it a little easier to see what's going on inside the model. And of course, I'll put in my distance right there of 20 millimeters. All right. So we have those blue dots at the end, meaning they're not connected, but that's okay. I can still use the rib tool to just pick that, because the rib tool is knowledgeable enough to extend the profiles out to any part that it intersects with. We can also extend it normal to the sketch plane. And I sketched it, on a plane that was cutting through the part. So we got a rib that's kind of halfway in that back direction, normal to the sketch plane. So I just need to put another rib, same conditions, essentially just pick that same profile, tell it to be normal to the sketch plane, extend it to part, and we're good to go. All right. And we got that weird kind of inset in there that I need to get rid of. So I'm going to use our powerful delete face operation to pick this fillet and that face. And just like that, it will heal it. Okay. I mean, that's pretty good direct editing right there, right? So now we have this nice kind of pocket. Maybe I want to make the walls a little thicker around there. So more move face operations. I'll just pick those inside radii right there. And now we have this nice radius that we can pop out, or wall thickness of 2 millimeters. All right. There we are. We'll just round off the inside of that, break those corners. It's looking nice. All right, let's just pop out a section view, Shift X if you're on your keyboard person, but you can see there's my nice cut through right here. I can see my rib looks good. I'm going to edit the other fillet to break the corners on the underside as well. This is a casting, so we're going to have some rounded corners. Now, we need to accommodate for the motor inside this design, of course. We also need to accommodate for the lid kind of snapping on into place as well, like a groove that goes around this. And because we're in a multi-part studio, this becomes very easy. What I'm going to do is I'm simply going to make this part overlap with the base. So I'm just going to take the cover and push it down by a certain amount. Let's see, 5 millimeters, maybe 2. And you can see in red on the screen, that's the interference automatically being shown in the section view. But that's okay, because we're going to use our Boolean operators here to subtract the cover from the base. And of course, we can keep the tools because, we want to keep that cover. Now we have a nice lip and groove here, type of construction, on the outside. Okay, let's go ahead and create an assembly now of our components. I'm going to rename this tab here at the bottom that was just waiting here for me to the name of the assembly and insert the 2 parts from the design part studio. Yeah, I'll just fix the base in place as the first component, and we'll just drag off the cover here. And you can see it's, there's no mates on the cover. And in fact, there really don't need to be, because we designed the cover in the context of the base, right, in the same part studio. So we're going to use the group option here to group the 2 parts and just rename it to the cover. But there are other parts that I have in my company that I've already imported into my Onshape account, right? I have a motor that I'm looking for. I can't quite find it, so I'm going to search for it, right? I'm going to look based on supplier. I've put Bueller Motor Company here as the supplier for this particular motor. And there it is. There's a Rev A released assembly for a gear motor. And I just drop that in. And it's just dropping it on the origin. I can drop that in any place. But note how you can mix and match released and in progress information. So this is the PDM capabilities that are starting to ripple up now through this demonstration, as you can see. I want to mate the motor so it's centered on the well. So, let's just look at this in a section view to make it a little easier to see what's going on. And we'll add a fastened mate to mate the center of the motor to the center of the underface. It shows us in red any interferences, just like before. So really cool that we can just mate in one click or 2 clicks, from one mate connector to another. It's just the mate connectors are appearing on the fly, based on the geometry. You don't have to do anything special to make those appear. It's one of the most clever things in the Onshape assembly environment. It makes it a lot faster to figure out how to put assemblies together. There's many benefits to this. Now I'm going to in-context assembly modeling at this point. We've gone back to the part studio for the design, but we've used a ghosted reference of the context of the motor placed at the assembly. So this is managed in-context design inside of Onshape. We'll just go to hidden line view here so we can see a little better, because I want to create the holes, for an M3 perhaps screw that's going to attach the motor to the underside here. We'll just switch this. Here's the hole tool. Pick the points that I copied from the underlying geometry there. It's a linked copy, using convert entities, of course. Let's go to isometric standard here for a tapped hole. We'll go down to M3, I think. Yeah, that looks good. Of course, you can put in, thread, your thread pitch, thread class, all those kind of things are right there, ready at your disposal. All right, so we have the holes, we have the removed center portion for the shaft, and the motor to set in there. And we're looking pretty good. Let's rename this to the motor interface, right? It's always good to rename the context, because you can have more than one context of a design in context in Onshape. All right, so looking good. Now, this is just a simple example here. There's lots of other things that are going to be required to build a final product here, but hopefully you're getting the point of what the design process here is inside of Onshape. For example, here's another design that I have created earlier. This is designed natively in Onshape, sheet metal blade here. Got a stamped component, welded. And it's all one piece essentially here. And I'm going to snap that with a fasten mate, and we're going to rotate that into place so we get the D or the flat shape placed in there. And in our section view, this is just a fun little tip in the section view. Actually, let's just rename this mate first to the blade and rename this to the motor, just to make it easy to find in the future. All right. We're going to pop up that mate, by the way. any mate usually will provide you with the additional movement options, so it doesn't have to be centered. I'm going to pop that down by a certain amount. All right, let's test our motion next here. You can see the blade here. Let's just edit the section view by double clicking any face like that has a section on it and telling it to exclude the blade. So when we spin it, it doesn't get cut off. All right. What else is missing? We probably need to put some screws in, don't we? So let's insert. Same insert menu brings you to the standard content. So if you're used to things like SolidWorks or Toolbox or things like that this is similar, right? So you have, bolts, nuts, screws, washers, all that stuff. In here, you can select standard, just like the hole tool, and, add your hardware. Let's do a rounded head socket button head cap screw. We're going to say it's going to be an M3. And let's just pick some length, see what happens. Now I can pick just the edges of the holes I want to put the screws in, or the entire face, or drag and drop them in. There's many different ways of doing it. I like to just pre-select the edges and then just hit insert, and it just drops them right in. All right, let's see how deep those are. Of course, I could change those, lengths after the fact, of course. Now, of course, we are going to get a bill of materials for this, right? So, and an exploded view, for our drawing. So we're going to end up making a drawing. So the first thing I'd like to do is create my exploded view assembly process steps. Simply go to the exploded view tab, click apart, drag it up. It puts the explode lines in. You can rename these steps, which make it very easy to understand moving forward. Because with an Onshape document, you can share it with anybody, right? And they'll also get the assembly instructions for ease of building or disassembly. So there we are. We're just dragging up our parts. Each time you pick a part or group of parts, it will create another step. There's not a lot of manual dexterity needed to do this. Let's see. I don't want to move that down. I want to move the motor down, actually, don't I? So let's just cancel that. And instead of picking the motor on the graphics, I pick it from the tree to make it easier to select. And we'll just rename that as well. So now it's very clear what each of these steps signify. And the name of the exploded view can also be set to their purpose. All right, looking good there. We have a drawing. So created this drawing earlier, just created a 3-view drawing here, and I hit the refresh button to regenerate the drawing with the latest information, which includes the exploded view, of course. And there we are. Now, of course, we can position this so we can fit a bill of materials on here. The assembly has been capturing all the information, for the BOM, right? The part number, material, and those kinds of things. I'm just going to drop it right there in the corner. And there's my bill of materials. Of course, you can customize this to any column you want. A column set, Onshape Professional and Enterprise allow you to create, completely custom properties for this purpose. All right. So I'm just going to get that laid out. We probably want to make this text a little bit smaller. It's kind of it's a B-size piece of paper, and this text is a little bit big for an assembly drawing. I really should have picked a D-size drawing, which I could have done, but let's just show you how to change the size of the font to fit this piece of paper better. So we'll just go ahead, go to our table section for our drawing properties, and crank this down to 2 millimeter high text. All right. Just you can drag that down. It snaps there. We can drag each of the columns out. And, depending on how much of a type A personality you are, you're gonna have fun just getting it to look the way you expect it to look. All right. But all the information is there, right? The supplier, materials, weight, the call outs can also use all of that same information. If you want to put a balloon call out next to any of the parts, I'm just going to drop in item number, quantity, and put a little X next to it, so that, it's clear. I don't know. I think it was like my first drafting class when I was making, parts back in, high school. I loved this style of doing balloons with the quantity next to them. I don't know. It's my preference. All right. We're looking pretty good right there. Now we need to get this released for production. All right. This is where the rubber meets the road. So we're going to add our drawings that are already part of here. I had created a drawing earlier of the cover of the coffee grinder. And it finds that because it was referenced to a part that I'm releasing. So this is equivalent to an engineering change order. If you really think about it, that's why I'm naming this release as an ECO. It's a special version that gets applied to all the parts that are referenced here. And you can add a comment and submit this for approval. I can have an entire team of people that needs to approve it. I can also let my manufacturing or manager team know that this is coming down the line. We have all of our part numbers already filled out, and it's checking everything there. And I just hit the, submit that for approval. It will share it with anybody who doesn't have permission to see it. We are. Let's hit the share button. So just like that, they would be getting email notifications saying, hey, this thing's waiting for approval. You should take a look at it and sign off on it virtually, right? So that is all right. So next, what I think would be a great idea is to do some marketing renderings while waiting for the rest of the sign-offs and approvals to occur. To do that, let's we want it to be a nice rendering of full assembly here. So we'll just hit a new tab here for a render studio. And it will find any elements inside of our Onshape document. It's spitting up advanced GPUs on AWS. You don't have to worry about any of this. No credits needed or anything like that. You just need an Onshape professional or above account. And pick the part, studio, or assembly that you want to do a rendering of. Of course, it has version management knowledge, of course. So you want to make sure you're choosing the correct version, of the assembly that you want to do the rendering of. So it just loads that right in, and it gives us a photo studio to work in now to start doing our live render session. So the first thing I think I want to do is find some better materials. So let's use our search tool. We'll just set the cover as like a clear acrylic. Right there, you can see acrylic came in, but I can choose an overriding acrylic. I'll just pick it in the tree and right-click and assign it. You can see it's giving you a really realistic view of this. It's got the index of refraction. You can see the through the glass there. Let's set some aluminum as the base right here. And I usually just search for aluminum, and there's many different grades and styles of aluminum, hammered and brushed and cast and those kinds of things. So, it's all about experimenting in what looks good here in our setup here. So I'm going to use a brushed one because I think the actual design, now that I look at it, is a nice brushed texture, on that part. That looks great. I think it's actually vertical instead of horizontal. We'll get to that point in a minute. But you just kind of get it looking the way you want. You get it positioned. And you just kind of find, the look and feel that you're looking for. It's it's all about composition here with the render studio. Think about being a photographer, and just thinking that way is going to be very helpful when using the render studio. You can clean up some unused appearances here. You can notice I'm going to go through the tree here and start selecting a bunch of parts ahead of time, if that's a word. And I'm just going to search for stainless steel, brush stainless, establish that on those components, the cap screws and the blade and the motor shaft. Okay. It's starting to look pretty good. I mean, just sitting here without it even, doing a full render. You can also place this thing inside of an environment, which can be a full immersive environment or just the lighting from an environment. Like here's a sample restaurant, that I selected. Gives it some nice kind of lighting. But we need to reposition this if we want to use it. I've set the hemispherical setting so that it will appear as if it were on the floor here. I'll show you where you can find that in a minute. But let's just go back to solid background first before we get fancy with the backgrounds, actually, now that I think about it. So we're using the background as just the lighting and the reflections, and we're telling it to override the background with a solid color. Just by going to the background checkbox. So, just kind of see what looks good. There's I'm a little colorblind myself, so just I always like to try to experiment with the different color schemes, see what looks good. Looking at it from an orthographic angle, like right from the side, is a helpful technique to create some nice realism, seeing it set in its natural environment. All right. Now, once you get closer to the time when you want to do the final render, you can upgrade the tessellation of the design so it's less sharp. You don't want to see the triangles behind the scenes, that make up any 3D model. You can crank up the tessellation to smooth out those kind of jagged shapes that you see on rounded components. And once you do that, you just do your render. You can tell it whether you want to include the background or not. Set your resolution, quality, and it will render in the background. Your computer is not being taken over when you're doing this rendering. You could go to any other tab inside of Onshape and continue your design work. I can even, kind of check out, what's going on with my approval process, right? And, this is what it would be like to release that design package. I told you I was going to do a rendering while I was waiting for the approval. This is what that approval process would look like. And, that drawing package is now approved, right? I can see it right there, that all that activity happened. So all this is happening in parallel, while renderings are happening, right? And there we are. And I'm looking at the released version of those two parts with the triangles next to them. I can go to my drawing. There's no watermark on this drawing. This is the part drawing. It already filled out my rev block. If I look at my assembly drawing, I should be able to check that as well and make sure that everything is filled out appropriately with my rev block, the approvals on the title block, so on and so forth. And I can always look at the release information, export things out from the release package if I needed a step or a PDF or whatever. For whatever reason, I could get to that. People didn't want to take a native Onshape link. It's kind of like, sharing a Google Doc by PDF, right? If you really think about it, that's a lot of extra work that's unneeded in many cases. I know there's contractual requirements and things like that for certain things. All right, let's just go back to that rendering. Here's a little bit more of an advanced rendering. We'll just go jump back into the render studio here. And I want to show you what I would do if I wanted to have a nice background, for this coffee grinder placed in here, right? So I would want to download a higher quality background if I wanted to show a background, because the backgrounds that come with the system are not like 4K or 8K or anything like that. They're fine for lighting, but if you really want to show the background in the context of this coffee grinder, I think it's worth going through these steps. Before I do that, I just want to fix the rotation angle of the brushing on the aluminum base here. So I just select it out of the tree here, go to the appearance tab, and I can change my rotation. I'll just rotate that 90 degrees. Yes, that's the way it really should look. All right, I like that. And if there's any other material changes, I might do that now. We have this round corner option that will round any really sharp edge. I turn that off because I already have physical rounds on the model. All right, let's collapse that. I think, let's do a rendering of it like this first, just without a background. And while that is rendering, we can then go to a website called Polyhaven. All right, let's switch tabs here. We'll go to polyhaven.com. And this is a great site that you can get textures and other resources from HDRA images for the background. This is, I come here all the time to get the appropriate background, right? Maybe I'm looking for a kitchen. I search for a kitchen, and then I can, choose the one I want, download, whatever quality I want, right? Here's a 4K download, 22 megabyte background file here. Highly encourage you to support Polyhaven if you're using some of their images. All right, let's import that image now into our custom background choice and upload that right in to our design. I'll create a version. Of course, I've changed the design or the version information of the design, so I'm going to up version the document, which will allow us to use this image. And you can see the color effect is dramatic right away. Without even showing the background, we have the effect of the background with the nice kind of amber sunset kind of look here. And of course, if I uncheck this actually, let's just do it this way. If I apply lighting and background, that'll force it. I have the hemisphere checkbox turned on, which placed it on the ground, essentially. And then I can switch to that different HDR image. These hemisphere images are kind of funny, right? Because they kind of compress and squish at the bottom, if you notice in the background, right? If I turn that on and off. But it's fine because once you actually do the render, you're not really going to see that detail. It's going to bokeh out in the background, right? So, if I enable depth of field and, focus on a part of the model with the lens that I'm going to have, you're not really going to notice that unless you know it's there personally as the photographer. But to the end user, right? It's background information. You're highlighting the image, and I can even put a reflective surface on the bottom. Change that to be a little less shiny, so it's a bit more realistic. You have a nice surface here. You can change shadow intensity, crank that up a little bit if you want to change the drama there. increase the roughness of the reflection. That's looking pretty cool. Now, of course, rendering is all about playing. You can, play with it with the cover on and off so you can see, what's going on inside of here. You can see the brushing really looks pretty realistic, with what you're seeing right there. And once you, get the angles that you're looking for and in the images, save those images right to the Onshape document. That way they're part of the collection. If you have approval processes for those kind of things with marketing, you could certainly do that as well with the Onshape release management. You can download these as any format and, post process it in any other application, Photoshop and things like that. There's all sorts of options for getting the alpha channel out and things. And here's a quick example of a final render, using the high resolution output.